And I am Miss Chan, and welcome to my home. And this is a video going over these problems right here. And I should provide some links below to go straight to those problems. Let's start with finding the area of a trapezoid. So to find the area of a trapezoid, we use this formula, A equals B1 plus B2 in parentheses times the height divided by 2. Let's go ahead and find those lengths, starting with base 1. Base 1 is this 8 right here, and we're adding it to the base 2, which is 3.4. Once we add those two together, we can multiply by the height, and in this case, it is 5. Notice this 5 is not going to be the same as this length. This is very, very different, and this is much longer, so don't be tricked by those problems. We're also going to divide by 2. When you add 8 plus 3.4 and multiply by 5 and divide by 2, you should get the area is 28.5. Notice we are given units, so we need to provide that as well. Our units are yards. And since we're talking about area, that's very important to also include 8 squared for 2 dimensions. Since we're covering area, it's two-dimensional. Makes sense. Now we're going to do number 7, which is to find the area. The way I taught you guys was to use the area of a triangle first, and then find the area of the polygon. Notice this polygon has 8 sides. So let's first go ahead and try to find the area of this triangle. And notice they give you the base, which is 6.1. This is 6.1 right here. The base is 6.1, and then the height is 7.4. And we're going to divide by 2. That's the area of a triangle, base times height divided by 2. When you put it in your calculator, you should get a number, and immediately you can take that number and multiply it by 8, because we know that there are 8 of these triangles in this octagon. When you multiply it by 8, you should get 180.56. And notice our units are given in this problem. But units are not given in this problem, sorry guys. So we write units, and it's squared because it's two-dimensional. Alright, let's move on to number 13, which is asking about the surface area of this figure. And notice it's a pentagonal prism. I've told you guys before that the surface area of a lot of prisms can be summed up as this. 2 times a base face, which is the area of a base face, plus the sides of this object. And I know that doesn't tell you much, but I'm going to show you how you can break it down. Let's start with the base face. The base face of this object is this pentagon right here. And notice it's different per object. Number 14, it's a pentagon as well. But for number 11, it's a triangle. Just keep that in mind. Let's go ahead and find the area of this base face. And again, it's just like before. We're going to use the area of this triangle first. And let me start that off. So to find the base face, you first want to find the area of a triangle. And notice you're multiplying it by 5 because there are 5 triangles in that figure. So I'm going to keep in mind that whatever I find, I'm going to multiply that by 5 because there are 5 triangles. Let me go ahead and write the area of a triangle. Base times height divided by 2. In this case, our base is 10, and our height is the apothem right here, which is 6.9. Notice we just found the area of a triangle, and we can just multiply that by 5. And you should get a number, duh, But what you also want to do is you also want to take that area and multiply it by 2. That 2, not only does it come from the formula, it comes from the idea that there are 2 of these pentagons, the top and the bottom. And that's very valuable to recognize. So I'm also going to multiply these numbers by 2. And your final result should be 345. Notice we're not quite done because we also need to find the surface area of the sides. That's this second part right here. And notice the sides in this situation are rectangles. We've seen a lot of rectangles in these surface area problems, and all we have to do is really just find the dimensions of these. For this rectangle right here, it's 10 by 12. So the area of one rectangle is 10 times 12, which is 120. But notice we need to find the whole surface area, and notice there are 5 of these rectangles. So I'm going to multiply 120 times 5 because there are 5 rectangles. So 120 times 5, the area of all 5 rectangles is 600. And finally, we can calculate the surface area. The surface area is 345 plus 600, which is 945 feet squared. Notice I'm squaring it because it's surface area. Even though we're talking about 3D shapes, we're only caring about the outside area. It's a two-dimensional idea. So that's why it's feet squared. So for number 15, we're still finding the surface area, but now it's a trapezoidal prism. I'm going to break it up just the same. We have the base face, which is a trapezoid, and to find the area of this trapezoid, we need the area formula. I'm just going to fill it right in. It's base 1, which is 5, plus base 2, which is, not 16. Notice it's this length right here. So don't make a mistake like me. Is 9. And your height this time is 4.6. We're going to divide that by 2. And you should also keep in mind that there are 2 of these trapezoids. So I'm just going to go ahead and multiply all of those by 2. When you calculate it out, you'll get a nice number, hopefully. Let me jump right ahead to finding the 4 sides. So the 4 sides are the harder part because some of them are the same and some of them aren't. Let's start with this one right here on the right-hand side. This is actually a rectangle, even though it doesn't look like it. It's just slanted, but the dimensions for this rectangle is 16 by 5. Notice this 16 right here kind of tells you how tall it is. Let's also talk about this top rectangle right here. This is actually a different size from the original rectangle. That top rectangle is 16 by 9 because of this 9 right here. If we look on the left side, on the very, very back, we have this rectangle right here. And looking for us, it's the same exact length as this length right here, which is a length of 5. So we can say that area is 16 by 5 as well. And let's not forget that bottom area down there. That area is 5 by 16. Or 16 by 5, doesn't matter. When you add all of these together, you should get a number, and you should also add it with the number that you got up here. And the total amount that I got for the entire surface area is 448.4, and the dimensions, or the units, are inches squared because it is a surface area. So now we're going to talk about number 27, which asks us to find the volume of these figures, and I'm going to help you guys out on number 27 because it's something we haven't really covered too much. We haven't really talked about cylinder or volume, but essentially we're thinking about how much space it would take up if we just poured a bunch of water in here. That's supposed to be water. And that's essentially what volume is, how much space something takes up. And to calculate that, I gave you guys a formula, which is basically volume equals the base face times the height. And be careful, it's not just two base faces like last time. It's actually just one base face. So I'm just going to write a 1 right here. And first, to find the one base face, in this case, it's just going to be that circle right there. And we know the area of a circle. It is pi r squared. But we don't really have r in this case, so we have to figure it out on our own. Notice r is from the center to the outside, and since we know it's half of this length, we know half of 18 is 9. So let me go ahead and put that in. Pi 9 squared, and all of these are multiplied. Let's think about the height. Notice the height is this right here, which is 7. So I'm going to multiply everything by 7. When you go ahead and throw that in, you can get pi times 81 times 7, and you can just throw it into your calculator. You don't even need to calculate pi all out. I'm okay with you guys just leaving it as 576 pi, and don't forget the units, which is centimeters. And this is volume this time. It's 3-dimensional, which means you need a cubed. Surface area, even though it deals with 3D shapes, we only cared about the area around it, which is 2-dimensional. This time we're caring about volume, which is always 3-dimensional. Oh man, guys, this one's a doozy. We're now going to find the volume of number 29, which is a trapezoidal prism. And again, the formula is one base face times the height. And I remember a lot of you guys struggled with this, so I'll try to help you guys out with this one. First of all, the base face is a trapezoid. So let's go ahead and try to find the area of that. Area of a trapezoid is 6, the first base, adding with the second base, which is 11, multiplied by the height. This is where it gets tricky. The height of the trapezoid is this red line right here, and I'm going to write it in red right here, 4.3, and it's all divided by 2. So that's the area of the trapezoid. And in addition to this, we're also thinking about multiplying it by the other height. And I think this is where a lot of people got confused. The other height is basically how tall something is. And it's confusing in this one because notice this looks like it's how tall it is, but it's not. It's actually this height. Basically, this is the length and how far that trapezoid goes back all the way to that back trapezoid over there. And we want to basically multiply it by how many of those trapezoids it takes, which is 8 feet, I cannot write, 8 feet long. This is from this length right here, which is also this length as well. Basically what we're doing is we're copying a whole bunch of trapezoids right here as far as 8 feet back. This is the height of the prism. You can also imagine it as taking the prism and flipping it, kind of like this, where you take it and you flip it, where this is the height, even though it's technically sideways in the picture. Hopefully that helps. Here's my Fruit Loops. When you go ahead and multiply it out, whatever number you get here, you should get your volume as 292.4 feet cubed. And if you don't, maybe let me know and I can help you out. But always check your math and see if you're putting it in the calculator right. So we are now done with area, volume, all that stuff. Now let's talk about finding arcs and central angles. So notice in number 35, they want us to find the measure of I, K. And notice it's an arc, so it's this length as an angle right here. That's our goal, the measure of IK. And notice they give us this information that this right here is 110 degrees. And we know for a fact that we actually know the entire distance around a circle. We know it's 360 degrees. So we can basically set up an equation. We can say 110 plus something equals 360. And notice I put two spaces right here, and it's because of these two spaces right here. Notice there's these two red marks, and that actually is a secret geometry code. It's actually not a secret, but it basically means that these two are the same length. Sometimes I write it like this. And if they're the same length, that means we can represent them as the same letter. Let's just call it x. You can now set it up as an equation, 2x plus 110. Sorry if I switched them. It's the same idea. Is 360. You can then solve it like a normal algebraic equation, and you should get x equals 125 degrees. And you are hunky-dory and fabulous. So now we're going to do number 47, and I chose number 47 because it's a little bit more challenging than the other problems. Notice we're trying to find the arc of C, F, and D. So notice we're pretty much finding that entire angle all the way around that circle except for this. So it's going to be a little challenging, but basically we can break it up into pieces. Notice they tell us that this is 58 and this is 45, and we're going to use that to our advantage. Automatically, I see some diameters, and I'm going to highlight them in yellow. Let me do it in yellow. Notice this is a diameter right here, and notice this is a diameter right here. And that actually is super significant because that basically tells us we can find missing pieces using the fact. Basically, I see that this angle is going to be the same as this angle right here because of vertical angles. So this whole thing is 45 plus 58. And I believe that is 103. So basically, we're almost there because now all we have to do is find this missing piece right here. And we know for a fact this is a straight line. This is a diameter. And we know all diameters are 180 degrees. That half of a circle. This half of a circle. So couldn't I just figure out what plus 103 gives me 180? So I could do that. 180 minus 103. And you should get 77 degrees. Notice you're not quite done because you've found all the small parts, and now you just have to add them all together. And you can do 103 plus the 77 you found, plus the 45 plus the 58 that you were given. And that's your entire length around C, and then F, and then D, and you should get 283 degrees. You can also do it where you find this, which is 77 as well, and then you can basically subtract it from 360. So you can also do this, and you should still get 283 as well. So either way works. Hello, and thank you for making it to the end of this video. We are now doing the last problem, number 49, which is to find the area of each sector. And here's our sector right here, this darkened big pie piece. That's one big piece of pie. And we want to find the area of this. So I've probably given you this formula. The area of a circle sector is theta over 360 degrees times pi r squared. Now all we have to do is just find those missing pieces, and we know theta. Theta's right here, 135. So I'm going to place that in. And we have 360 degrees down here. And we know the radius. The radius is 9 kilometers. So 9. Sorry guys, that is 19. I can't read. So we have pi 19 squared. Let's go ahead and simplify this. Again, we're finding the area. If you put this in the calculator, this fraction right here, it actually simplifies down to 3/8. And 19 squared basically becomes 361. And I thought this was just interesting to point out that if you look at this picture, basically 3/8 comes from the fact that this is 3/8 of the circle. So we're literally just calculating a fraction of the circle. All we have to do is just now multiply them all out. Again, you can use pi as 3.1415. And when you use your handy dandy calculator, you should get 425.3. And then kilometers squared, I'm using squared because again we're using area, and area is two-dimensional. Thank you for making it to the end. Good job. And you can always email me if you have any other questions about this packet. I have also attached the answers below in the description. Let me know if you have any questions.